Let's continue our chapter for probability. I'm going to concentrate on multiplication rule. We talked about addition rule last time. So now first of all, let's review a little bit on the addition rule. So addition rule basically probability of A union B equal probability of A plus probability of B minus probability of A intercept B. Okay, so let's take a look at this example. A single six-sided die is rolled. What is probability of rolling a number greater than 3 or even number? Okay, so number greater than 3 it could be 4, 5, 6. And then the even number will be 2, 4, 6. As you can see, you have two common sections or two intersect. So if you draw the Venn diagram here, okay. So 4, 6 is common numbers. This is greater than 3. The other one is even number. This one is even number. Okay. And to be just 2. And remaining numbers 1, 3 will be outside of those two circles. So now probability of greater than 3 union even number should be probability of greater than 3. Adding probability of even number, and then minus probability of greater than 3 intercept even number. Alright, so greater than 3 will be 3 over 6. Even number 3 over 6. The intercept between those two will be two numbers 2 over 6. 6 minus 2, which is 4 over 6. Reduce it is 2/3. So probability of this greater than 3 or an even number will be 2/3 of the time. Now let's take a look at basic concepts on the multiplication rule. So basically we focus on P, A, and B. You can also say this is A intercept B. Okay, intercept B is a common section to the Venn diagram. It's both A and B occur at the same time. Looking at this. And this is intercept B. So this is probability that event A occurs in the first trial and event B occurs in the following trial or second trial. If the outcome of the first event affects the probability of the second event, it's important to adjust the probability of B to reflect the occurrence of event A. And we call this conditional probability given that event A has impact on event B. So P, A, and B, A intercept B, meaning both A and B occur at the same time. So the general rule is probability of event A times probability of event B, given that event A occurs. Okay. So probability of B given that event A occurs represents the probability of event B occurring after event A has occurred. So we call this conditional probability. So probability of A and B intercept B, probability of A times probability of B given that A occurs. So finding the probability that event A occurs in one trial, event B occurs in the next trial, simply just multiply the probability of event A by the probability of event B. And also we need to take into account that previous occurrence. Event B takes into account of the previous occurrence of event A. Applying the multiplication rule, always consider whether the events are independent and dependent. Independent meaning event A has no impact on event B. Dependent meaning event A has impact on event B. Adjust the calculation accordingly. Multiplication rule for several events. In general, probability of any sequence of independent events is simply the product of the corresponding probabilities. So for example, if let's say probability of A intercept B intercept C, intercept D. So basically, if they are all independent, assuming event A, B, and A, B, C, and D are independent, we just write it as probability of A times probability of B times probability of C times probability of D. For example, let's say you flip coin 4 times. Find the probability of getting 4 heads in a row. So basically, apply this rule. Probability of getting the first head will be half. Probability of getting second head is half. Third head is half. Fourth head is half. So it turned out to be 1/16. So that's the probability of getting 4 heads when you flip a coin 4 times. 2 events A and B are independent. The occurrence of one does not affect the probability of occurrence of the other. Several events are similarly independent if the occurrence of any does not affect the probability of the occurrence of others. If A and B are not independent, they will be dependent. We claim they are said to be dependent. Let's take a look at this example. Suppose you take out 2 cards from a standard pack of cards, one after another, without replacing the first card. So without replacement here. You pick the card, you remove it from the standard deck of the cards. What's the probability that first card is the ace of spades, second card is a heart? First of all, these 2 events are independent, because ace of spades has no common intercept with the heart, so they are independent. So we're applying a multiplication rule. Applies. So probability of getting ace of spade intercept probability of getting heart. So the probability of ace of spade times probability of getting a heart. Probability of getting ace of spades, only one ace of spades, so it's 1 over 52. Now since you remove a card from the deck, you only have 51 cards left, and we have 13 hearts total. So this should be the probability is 13 over. Then we can reduce it. 13 going to 52 4 times. So let's reduce it. So it's going to be 1 over 204. Probability is 1 over 204. That's the exact fraction. Okay. So that's how we apply the multiplication rule to solve the probability problem. So two events are dependent if the occurrence of one have impact on the probability of occurrence of the other. Does not necessarily mean that one of the events is the cause of the other. A 5% guidance for cumbersome calculation. If the sample size is no more than 5% of the size of the population, then we treat the selections, we treat the sample as independent. So sample is independent. If the sample size is less than 5% of the population, even if the selection are made without replacement, okay, we still treat them as dependent. Okay. So suppose 50 drug test results are given from people who use drugs. So we have 44 positive test results, and we have 6 negative test results. Total result is 50, so basically sample size is 50. If 2 of the 50 subjects are randomly selected without replacement, find the probability that the first person tested positive, second person tested negative. Now one more time. First positive, and just a second negative. So again, they are independent. We're assuming they are dependent. So first positive result using multiplication of first positive times probability of second negative. First positive will be 44 over 50. Second negative, since we're picking one, is already is 49 subjects remaining. Now we have 6 negative test results, so 6 over 49. Now we could simplify this, or we can turn into decimal numbers. So 44 times 6. 264 dividing by 50 times 49, 2450. And if you divide into that, 264 divided by 2450, turn out to be 3 significant digits will be 0.108. So if you turn it into percent, it will be 10.8%. There's a chance. You get a first person test positive, second person test negative. Again, independent. It's assumption. When two different people are randomly selected from those in your class, find the indicated probability by assuming the birthdays occur on the same day of the week with equal frequencies. If probability that two persons are born on the same day of the week. So we have 7 days in a week. Now they're born on the same day, we have 1/7 chance. 7 days, either one of they born on Monday, they're okay. On Tuesday, born on Wednesday, so 1/7. Two persons are born on the same day. Probability that two people are born on Monday. Okay. So first one born on Monday. Second one on Monday. So 1/7 chance first person is born on Monday. 1/7 chance second person is born on Monday. So it turned out to be 1/49. That's the probability. Those three people are randomly selected, so they are independent. Okay. They are not related. They have no impact on each other. The tree diagram is a picture of possible outcomes of procedure, and we use to determine the possible outcomes, all possible outcomes of sample space. Now let's take a look at this using the tree diagram. Find the possible outcomes for a true-false question followed by a multiple choice question with 5 answer choices. So we can also create a tree diagram starting point. First outcome, you either get true or false. Okay. T represents true, F represents false. And the second question, you have 5 choices, either A, B, C, D, or E. Second question, A, B, C, D, E. Now follow the branch of tree, we get all possible outcomes. We get 10 possible outcomes: TA, TB, TC, TD, TE. Second half of the branch, FA, B, FC, FD, and FE. As you can see, we have 10 possible outcomes here. Also, you can look at another way of looking at this is you look at the first, you get 2 choices. Second one, you get five choices. And independent, using the multiplication rule, we get 10 possible outcomes. Okay. And you want to get both questions answered correctly. Probably the poll question, both answer correct, both correct. You have one possible correct combination, so it's 1/10. So in the addition rule, PA or B, same thing as PA union B. Everything A, everything B, and then intercept of A and B. Here suggests addition. Okay, so whenever you see all things using addition rule, whenever you see and it's multiplication rule. And pay probability of A intercept B. Okay, and we're using multiplication rule PA and probability of B given that A occurs. Okay. In the multiplication rule, the word and suggests multiplication. Okay. And to make sure to to make sure that probability of event B takes into account the previous occurrence of event A. So when you apply the multiplication rule, be sure to make sure they check the independence, whether they are independent or not. If they are independent, then multiply probability of A times probability of B. If they're not independent, you do probability of A times probability of B given that A. So we are using the conditional probability to find out the probability of B.